Welcome everybody. We are expected to integrate this. Foremost, let me consider integral 0 to 6 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt. I'm going to rewrite this as 0 to pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt, positive pi to 2 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt, positive 2 pi to 3 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt. So this is 3 pi to 4 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt dt, positive 4 pi to 5 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt, positive 5 pi to 6 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt. So this is what we have got. Okay. Now I would like to write the left hand side, this component, as I1, 0 to pi as I2, pi to 2 pi as I3, and 2 pi to 3 pi as I4, 3 pi to 4 pi as I5. Let me check. This is I2, I3. I3 is okay. This is I4, and this is I5. This is I6, and then 5 pi to 6 pi is I7. Okay, so this is what we got. Now what is my objective? My objective is to represent I3, I4, I5, I6, I7 in terms of I2. Now what is I2? This is my I2. Okay, so this is our target integral. Every integral we have to represent it in this fashion. Okay, so having mentioned that, let me consider I3. I3 is integral pi to 2 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt. Now let me take t is equal to pi positive x. So therefore when t is equal to pi, my x will be equal to 0. When t is equal to 2 pi, my x will be equal to pi. Now when I substitute, okay, let me do this. dt is going to be equal to dx. When I substitute t is equal to pi positive x, there won't be any change in the integrand. Having mentioned that, this new integral is going to be 0 to pi e raised to the power of, in place of t is going to be pi positive x times sine of 6 b of, as I mentioned to you, this is going to be producing me a x here, followed by cos raised to the power of 4 bx times dx. Now this can be rewritten as integral 0 to pi e raised to the power of pi times e raised to the power of x times sine raised to the power of 6 bx positive cos raised to the power of 4 bx times dx. I can revert this back to integral 0 to pi. Now x I can revert it to t. So e raised to the power of t times sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt. Now what is this? This is nothing but our I2, right? So this is my I2. So what we have just done, we have written I3 in terms of I2. So having got that out of the way, let me go to the next integral, which is I4. So this has been from pi to 2 pi. My I4 is 2 pi to 3 pi. So I4 is 2 pi to 3 pi, right? So 2 pi to 3 pi e raised to the power of t of sine raised to the power of 6 bt positive cos raised to the power of 4 bt times a dt. So I substitute t is equal to 2 pi positive x, and when x is equal to 2 pi, or I would say when t is equal to 2 pi, my x becomes equal to 0. When t is equal to 3 pi, my x becomes equal to pi. So this is going to be 0 to pi e raised to the power of 2 pi positive x times sine of 6. This is going to give me bx, positive cos raised to the power of 4 bx times dx. Why dx? Because dt is equal to differentiate, I get dx. So this is my I4. I can rewrite this to be as e raised to the power of 2 pi times integral 0 to pi e raised to the power of x times sine raised to the power of 6 bx positive cos raised to the power of 4 bx times dx. So this is equal to e raised to the power of 2 pi. I can revert this back to the original integral, which is t. There's no harm in it, as I mentioned to you. This is sine raised to the power of 6 bt positive cos raised to the power of 4 bt times the dt. So this is going to be e raised to the power of 2 pi times, what is this? This is nothing but my I2. So this is going to be I4. Now I5 is 3 pi. I5 is what? 3 pi to 4 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt. Now following the same principle which we have been doing, following the same principle, this is going to be e raised to the power of 3 pi times I2. This is my I5. Now I6 is 4 pi to 5 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times the dt. So this is going to be equal to, this is I6, right? So I6 is equal to e raised to the power of 4 pi times I2. The same principle as I mentioned to you. Now I7 is 5 pi to 6 pi e raised to the power of t of sine 6 bt positive cos 4 bt times dt. And this is going to be I7 is going to be e raised to the power of 5 pi times I2. So this is my I7, this is my I6, this is my I5, this is my I4. So if you remember the original expansion, this is the original expansion. So let me take this as 1 and rewrite this. So therefore 1 can be rewritten as I1 is equal to I2 positive, I3 is e raised to the power of pi I suffix 2, and I4 is e raised to the power of 2 pi, right? 2 pi e raised to the power of 2 pi I suffix 2, and I suffix pi is e raised to the power of 3 pi I suffix 2, and 6 is e raised to the power of 4 pi I suffix 2, and 7 is e raised to the power of 5 pi I suffix 2. Okay, this is what we have got. So now I can take I suffix 2 out. I get e raised to the power of pi positive e raised to the power of 2 pi positive e raised to the power of 3 pi positive e raised to the power of 4 pi positive e raised to the power of 5 pi times I suffix 2. This is I suffix 1. But what is I suffix 1 actually? I suffix 1 is this integral. So let me write that down. That is e raised to the power of 6 pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt is equal to 1 positive e raised to the power of pi positive e raised to the power of 2 pi positive e raised to the power of 3 pi positive e raised to the power of 4 pi positive e raised to the power of 5 pi times I suffix 2. What is I suffix 2? I suffix 2 is this integral, right? So write that 0 to pi e suffix t of sine raised to the power of 6 bt positive cos raised to the power of 4 bt times the dt. So therefore the original problem, hence the original problem is 0 to 6 pi e suffix e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times the dt divided by integral 0 to pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt is now equal to, in place of this I substitute this. So this is 1 positive e raised to the power of pi, e raised to the power of 2 pi, e raised to the power of 3 pi, e raised to the power of 4 pi, e raised to the power of 5 pi times integral, what is this power? Integral 0 to pi e raised to the power of t or sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt. This is divided by integral 0 to pi e raised to the power of t sine raised to the power of 6 bt positive cos raised to the power of 4 bt times dt. Now this and this gets cancelled, giving me 1 positive e raised to the power of pi positive e raised to the power of 2 pi positive e raised to the power of 3 pi positive e raised to the power of 4 pi positive e raised to the power of 5 pi. And the common ratio is e raised to the power of pi, so we can rewrite this as 1 times e raised to the power of 1, 2, 3, 4, 5, 6. 6 terms are there, right? 6 terms are there. So this is going to be 6 pi negative 1 divided by e raised to the power of pi negative 1 for all b element of real numbers. Okay, so that is the end of this question. So this is the solution, and please like, share and subscribe. Thank you.